Okay, we're going to work on this again, Unit 7 for ACC300, Intermediate 1, exercise 6-11 and 6-12. So let's start with 6-11. Sosa Excavating is purchasing a bulldozer. The price of the bulldozer is $100,000. They have been offered a payment plan by the manufacturer that says, hey, give us 10 payments of $16,274 and the bulldozer's yours, right? So they're going to finance it. So how much interest would they be paying? So let's look at, looking at this problem, the total payments that we have, this is part A, so I'm just looking at part A. 10 payments at $16,274.53 is $162,700. I'm sorry, $162,745, right? And then yeah, subtract that from 100,000, which is the amount of the machinery you're getting, and the interest payment is $62,745. Compare that to the bank, right? So if we look back over here, assume they can go to the bank and borrow this at a rate of 9%. Is this amount that we're paying the manufacturer more or less than 9%? Well, that's a good question. So we know the number of payments, 10 payments. We don't know what I is. So what we need to do is we say, well, the amount of payments are 16,000. So the present value of the same amount of payments, the annuity, the value of the annuity is 16,274.53 times the factor PVOA, right? Which is let's see, I should have that for us. Table 6-4, right? Right. So if we go to 6-4, which is present value of an ordinary annuity, we need to know what that factor is, right? And once we figure that factor is, we can go out to that table and find what the interest is. So 16,274.53 times variable x, right? You can just make that x equals $100,000. So we need to divide the left side and the right side by 16,274.53. And what we get is the present value of the ordinary annuity, this is my variable, that's all one thing, equals 100,000 divided by 16,274.53 is 6.14457. So if we go to table 6-4 and look for n is equal to 10 and then go across that row until you see the rate that's closest to 6.4457, and you'll see that it's 10%. As a matter of fact, if I take you to table 6-4 and I go to n is equal to 10, I go down, well actually if I start here you can see n is equal to 10, and I'm looking for 144, if I keep going along the bottom, I need to go past 6% to, we'll go to 8%, 9%, so I'll go down to 10, this is row 10, and I get 6.14457, and that's how you can see that it's row 10. So that's how we know it's 10%. I said row 10, but I meant column 10%. Okay, so now we're on exercise 6-12. The Black Knights is a company that's trying to get a new building, right? So they need this building, and they have three options. They can buy a building outright for $600,000. They can buy a building they can lease a building for $69,000, or they can purchase a building that's bigger than they need for $650,000 cash and then rent part of it, right, that they don't need because it's bigger than they need. Okay. So what we need to do is we need to compare each of these, the present value of each of these buildings, and see which present value is the least expensive. We're going to assume that we're just going to go with the least expensive building, even though we know that sometimes buildings have other factors that we would use to make our decision. But in this case, we're just looking at the cost of the present value, right? So the cash, building A is we pay $600,000 cash now. So the value of $600,000 now is $600,000. So the present value is simply the amount that you're writing the check for immediately, because you're paying it right now. And B, in building B, we're going to lease for 25 years, making $69,000 payments. So looking at B, the payments times the present value for an annuity due. The reason this is an annuity due is because of the wording that says the $69,000 payments need to be made at the beginning of the year. As you can see here, the $69,000 being made at the beginning of the year. That means it's an annuity due. Alright, so present value of the annuity due factor is equal to the present value. So the table we're going to use here is 6-5. And so we know that the 25 years, and we know that it's 12%, that's provided for us. Let me just show you where it's in the instructions. It says in which building you would recommend assuming a 12% cost. Okay, so we know the 12%, we know this 25 is the number of periods. So we go to that table 6-5 and we get 8.78432. So 69,000 in payments times the factor, the present value of the annuity due factor, equals 606,118. So that's the value of making the payments now. So that's obviously more than 600,000. C is to buy a bigger building for 650,000, and then sublet. So the renting out the extra space for 25 years with getting $7,000 a month. How much money is that going to save us? So first of all, let's get the payment. We'll know what the $650,000 is worth because we're paying that right away. It's worth $650,000. But how much is that $7,000 going to save us? So we're going to be renting it out for 25 years, 12%. So we need to use the right table, table 7-4, or 6-4, table 6-4, and we go there and we say, well, 25, because we're getting the payments at the end of each year, so that's why it's an ordinary annuity. So present value of an ordinary annuity. N is equal to 25, I is equal to 12, table 6-4, we get this factor, times the $7,000 we're going to be getting. So that $7,000 is worth, that we're going to be getting every year, is worth right now, beginning of this, of the endeavor, $54,902. So we're going to be paying immediately $650,000. So the value of the building is $650,000 minus what we're going to be getting. The present value of the rental amount that we're going to be getting over the next 25 years is $54,902. We subtract that because that's what we're going to be getting in the future. And so we see that of A, B, and C, building C has the cheapest present value. Okay, so that's how you would, compare those three using present value tables. We're going to do the other problems in another video.